Today we're going to begin lesson 3.2, where we look at angles and parallel lines. In our previous lesson, 3.1, we started to look at parallel lines and planes, as well as the transversals that caused us to have some new angle relationships where we had interior and exterior angles. We had ones that were alternating or corresponding. So let's review. Number 1 here. Choose the plane parallel to plane MNR. MNR is this plane up here. Okay. We need something that is parallel to MNR. That's going to be somewhere here at the bottom. That includes either P, T, O, or S. Remember that we name planes using 3 letters. Okay. It's not going to include R. It is not going to include Q. And it's not going to include N. The only correct choice really here is POS. Choose the segment that is skewed to MP. Remember, skew means that we are not crossing, but it is not in the same plane. Okay, MP is this line right here. Okay, PM is the same line, just expressed in a different way. TS seems like a possibility. PO, that's this right here, and that would actually intersect. And MQ also intersects. So the only good answer choice here would be TS. Okay, number 3, classify the relationship between number 1 and number 5. Okay, they are both on the same side of transversal L. They're both on the same side of the lines that the transversal is crossing. They're both above. Okay, these are not vertical angles. We can either classify them as interior or exterior. These are corresponding angles. Classify the relationship between angle 3 and angle 8. Well, in this case, we can see that they are both on the same side of the transversal L, and both are to the interior of lines M and N. Okay, so they're not alternating. They're not switching sides. They're not corresponding because they're not both on the same side of the lines, but these are consecutive interior angles. Okay, classify the relationship between angle 4 and angle 6. Okay, these are on alternate sides of the transversal. They are exterior to M and N. We know they're not vertical. They're not corresponding. They're not interior. They are alternate exterior angles. Okay, last review question. Which of the following segments is not parallel to PT? So we're looking for the one that is not parallel to this segment here. OS. We have TS. Well, that looks like it's crossing. NR. And MQ. The one that is not parallel is TS. Okay, so we've named different angle pairs that were formed by these parallel lines and transversals. Now we're going to use some theorems to determine the relationships between specific pairs of angles. And we're going to use algebra with those specific pairs of angles in order to determine their measurements. So here's a new postulate, 3-1, corresponding angle postulate. If two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. Okay, 1 is congruent to 3. 2 is congruent to 4. 5 is congruent to 7, and 6 is congruent to 8. So let's use this corresponding angles postulate to determine some measures here. In this figure, the measure of angle 11 right here is 51. We need to find the measure of angle 15. Tell which postulates or theorems that you used. Okay, we just really went over the postulate on the last screen, the corresponding angle postulate. 11 and 15, those angles are corresponding angles. They're both on the same side of the transversal and both on the same side of the parallel lines. So angle 15 has a measure of 51 due to the corresponding angle postulate. 15 is congruent to angle 11. Since that's congruent, we know that their measures are equal. We substitute, and we have our answer. Okay, so with that in mind, we see this figure in which measure of angle 11 is 51 degrees. So we know that this is 51. We need to find the measure of 16. So previously we found out that if angle 11 was 51, its corresponding angle 15 was also 51. What relationship is there between angle 15 and angle 16? Well, 15 and 16 are vertical angles. 16 is congruent to 15, and 15 is congruent to 11. These are given by the vertical angles theorem and the corresponding angles postulate. Using the transitive property of congruence, we see that angle 16 is congruent to angle 11. If those two angles are congruent, their measures are equal due to the definition of congruent angles. And through substitution, we know that the measure of angle 16 is 51. Okay, in this figure, lines A and B are parallel. And we know that the measure of angle 18 is 42. So this angle has a measure of 42. We need to find the measure of 22. Okay, 22 and 18, those angles are corresponding angles. So due to the corresponding angles theorem, I know that 18 and 22 are congruent. Because they're congruent, they have the same measures. And so I can substitute in that the measure of angle 22 is really 42. Okay, in this figure, A parallel to B, and the measure of 18 equaling 42, we need to find the measure of 25. So we know this measure is still 42. To link over to 25, we can still use angle 22. So corresponding angles, corresponding angle theorem, we find that this is 42, and then using the vertical angle theorem, we know that this is also 42. Okay, some additional new theorems. Okay, these theorems are regarding parallel lines and angle pairs. We have a theorem 3.1, alternate interior angles theorem, that if two parallel lines are cut by a transversal, that each pair of alternate interior angles is congruent. Okay, the alternate interior angles. So here you see that for angle 1 and angle 3 are congruent, and then angle 2 and angle 4 are congruent. Consecutive interior angles theorem. This is theorem 3.2. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. So 1 is supplementary to 4, and also 2 is supplementary to 3. Okay. I could actually also state, as you see here, that 1 and 2 are supplementary, and 3 and 4 are supplementary. 3.3. Theorem 3.3 states alternate exterior angles theorem. Okay, the exterior angles, if I look at the alternate exterior 5 and 7, those angles are congruent, as is 8 and 6. Here's a proof of the alternate interior angles theorem. Okay, how they work out these proofs is they take that theorem, alternate, let's see, this was interior angles. So they take this theorem 3.1, and the if part of the theorem is what is given, and the then part is actually what they're trying to prove. And sometimes they'll put in a very specific example. So here we have A and B that are parallel. That's shown by these arrowheads that are on those lines. We know that T is a transversal of A and B. We need to prove that angle 4 is congruent to 5 and that 3 is congruent to 6. So they give us a paragraph proof. We're given that A and B are parallel with transversal T. By the corresponding angles postulate, the corresponding angles are congruent. So angle 2 is congruent to 4, and 6 is congruent to 8. 5 is congruent to 2, and 8 is congruent to 3 by vertical angles, the vertical angle theorem. Therefore, 5 is congruent to 4, and 3 is congruent to 6, because the congruence of angles is transitive. Okay, so now we're going to use some theorems about the parallel lines. This diagram represents floor tiles in Michelle's house. If we know that angle 2 is 125, we need to find the measure of angle 3. Okay, what kind of angles do we have here? Their relationship is that they are alternate angles. So we can use the alternate interior angles theorem, that the alternate interior angles are congruent to one another. Because they are congruent to one another, that means that their measure is equal to one another through the definition of congruent angles. Since that measure is equal, the measure of angle 3 will also equal 125 through substitution. Okay, once again, we have this diagram of floor tiles. The measure of angle 2 is still 125. We need to determine the measure of angle 4. Well, we had just proven in our last slide that angle 3 was an alternate interior angle with 2. It was congruent to 2, so that angle 3 also had a measure of 125. Okay, now you can see that 3 and 4 make up a linear pair. They're supplementary. They are consecutive interior angles as well. So they are going to add up to 180. So this angle 4 is 180 subtract 125, which is also equal to 55. Okay, some new lines here. We are going to work out how to solve for particular variables and find their values. Here we have two sets of parallel lines, okay, that can act as transversals to one another as well. P is parallel to Q, M is parallel to N. That's found by the arrowheads that are marking the lines. Okay, those pink or red arrowheads. We are given that the measure of angle 5, that's this right here, is 2x minus 10. And we're also given that the measure of angle 7 is x plus 15. And we need to determine what is x. Okay, these two angles are corresponding angles. They're on the same side of a transversal. They're also on the same side of parallel lines. Corresponding angles are congruent to one another. Okay, so I would expect to see something where x plus 15 is equal to 2x minus 10, and then we can solve for x. Okay, they use the corresponding angles postulate to say that they're congruent. We have that the measures are equal due to the definition of congruent angles. We substitute in the algebraic expressions that each of those measures are equal to. That's where we were. Solve for x by subtracting x from both sides. And then add 10 so that x is equal to 25. Okay, here we're given that the measure of angle 4, okay, this is 4 times y minus 25. And we're also given that measure 8 is 4y. So we need to find y. Okay, these are on the same side of transversal N. They are exterior to the lines. Trying to work out how these are corresponding angles. This does not seem right unless 8 were on this side. Okay, this would be true if this were on the opposite side of Q. Because they are corresponding, their measures are equal. This is only true if 8 is on the top side of Q and to the right of N. We can substitute in their values as a result, that the measure of angle 8 is 4y, and the measure of angle 6 is 4 times y minus 25 in parentheses. Okay, they say the measure of angle 6 and the measure of angle 4 is equal to 180. We can see that right here, that this is 180 degrees between the two of them. So that's going to give us what 6 is. Okay, Mrs. Leeson made a mistake here. She was thinking somehow that this was related to 4, but really they're showing how 6 and 8 are related. Okay, so no, this is definitely true. 6 is corresponding with 8. Okay, we need to know the measure of angle 6 in order to determine 8. And we can find that using angle 4. Okay, so this is 8 on the correct side. Angle 8 is congruent to angle 6 because of corresponding angles postulate. They're both on the same side of the transversals and are parallel lines. Okay, so their measures are congruent, and I can substitute in for 6 this expression for y. Okay. Now, to determine the measure of angle 6, I know that the measure of angle 6 and the measure of angle 4 is 180 due to the supplement theorem. So if I substitute in, I can say that 4y plus 4y minus 25 is equal to 180. I distribute the 4 to have 4y plus 4y minus 100 is 180. I can add, and then I divide to find y is equal to 35. Okay, here we have an expression for angle 1, and for angle 2, and for angle 3. And we need to find x. So there's different choices that we could make. Okay, we have alternate exterior angles. We also have corresponding angles. How would we go about solving this? Angle 2 and angle 3 are equal to one another since they are corresponding angles. So I could say 2 times 5x minus 3 is equal to 5y plus 14. Well, that doesn't really help us, does it? How can I solve if I have an x here and a y here? We need to know the relationship, really, between 1 and 2. Okay, so I know that these are alternate exterior angles. What is true about alternate exterior angles? Well, I'm going to take a look at my cheat sheet here. Alternate exterior angles. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. So 1 is congruent to 2. That is theorem 3.3. So by theorem 3.3, I can look at this as the measure of angle 1 is equal to the measure of angle 2. Okay, we know this because the measure, well, really, just that angle 1 is congruent to angle 2 because of theorem 3.3. Okay, since those measures are equal, I can now substitute in 9x plus 6 is equal to 2 times 5x minus 3. This is substitution. Okay, I can distribute. 9x plus 6 is equal to 10x minus 6. Okay, I can subtract and add. That I get x on this side. Subtract 9x, subtract 9x. Add 6 to this side, add 6 to this side, and I have x equal to 12. Okay, here we still have this same information, but now they need us to find y. Okay, we know what x is given our previous example, that we know that x is equal to 12. We had done that by relating angle 1 and angle 2. Well, now we need to add angle 3. We know that angle 2 and angle 3 are congruent because they are corresponding angles. Since they're congruent, their measures are equal. Because of the definition of congruent angles. So that means that our 2 times 5 times 12, due to substitution, subtract 3 is equal to 5y plus 14. Okay, we're substituting in the value of x, and we're substituting in the algebraic expressions for the measure of angle 2 and angle 3. Okay, so now we will distribute, actually multiply, then distribute. So let's go 2 times 60 minus 3 is equal to 5y plus 14. 2 times 57, 114 is equal to 5y plus 14. Subtract 14 from both sides. 100 is equal to 5y. And 20 is equal to y. So our answer is B. Okay, perpendicular transversal theorem. If we have a transversal that is perpendicular to one of two parallel lines, then it is perpendicular to both. In this case, if line A is parallel to line B, and line A is perpendicular to the transversal T, then line B is also perpendicular to transversal T. And now you're ready for your homework.